Good day, students. Today we are going to look at this paper, which was March 2024. It's paper 2AS, level structured questions. We're just going to look at question number 1. It was talking about an element which is called bismuth. It's an element in group 15 of the periodic table. Question 1A, it was talking about bismuth being an element that shows metallic bonding. Well, what is metallic bonding? Metallic bonding, in short, is actually an array of positive ions, cation ions that are surrounded by sea of delocalized ions. I think I suppose you know that the sea of delocalized ions are responsible for conducting electricity, even heat, across the metal lattice, for instance. So the diagram must actually show this regular arrangement of the positive ions surrounded by a sea of delocalized ions. So how would you actually draw the diagram? I can actually draw something which will be acceptable in the examination here. So you will need to draw your circles like these. Okay, these ones are going to show your positive ions. Okay, you need to draw better circles. I'm drawing it on the PC, so the circles might not come out very good. Okay, like that. Okay, so this is your positive ions. Okay, and then you have these mobile electrons which don't belong to any particular position. Okay, so there's supposed to be electrostatic attraction, so there should be opposite charges here. So an electron here, okay, and then you have a positive ion there. Okay, you have an electron there, and then you have a positive ion here. So obviously when you draw in your exam, you're supposed to draw good circles, but in essence, we just want a regular arrangement of the positive ions, and then they should be surrounded by a sea of delocalized electrons, okay? Right, so that is the acceptable diagram here, okay? Then we move on to the next question. What was the next question talking about? The next question was talking about bismuth reduces water to form bismuth oxide, a colorless gas that ignites with a squeezy pop is also formed. Okay, that's the complete story. They are actually guiding you as to what is going to be produced when bismuth reduces water to form bismuth oxide. Okay. Right, so we want to write the equation, the acceptable equation here, okay? This question is fairly straightforward because we've been told what's going to happen. So what we do, okay, we're going to have our bismuth, okay? Our bismuth is going to react with water, okay? I am going to write a balanced equation here, okay? So this is going to be my balanced equation. I'm just going to put equal signs, okay? In normal cases, you are actually supposed to put an arrow when you are writing this equation. What will be the product? Our product is going to be B2 O3, okay? To illustrate what? To illustrate the oxide that is produced when bismuth reduces water to form bismuth oxide. We've been also told that there is a colorless gas that ignites with a squeaky pop, okay? That squeeze pop suggests that hydrogen is actually produced in the process. So we are also going to write hydrogen like that. So this is the acceptable balanced equation, okay? At A level, they will just say equation, but because you have this background of balancing equations, you are supposed to write an equation which is balanced. Never write an equation which is not balanced at A level. That is not acceptable. Part 3. Bismuth is a yellow insoluble solid that melts at 1090 kelvins. The molten compound conducts electricity. Okay, right. Deduce the structure and bonding of bismuth oxide. Explain your answer. So the properties that we've been given there can be used to actually tell us the structure and also the bonding. So what we are going to do is we are going to mention the structure and then we are going to give a reason. Okay, right. So how are we going to answer that question? We are actually going to have a property and then we also write our reason. Okay, right. So what we do, let's just write our answer as follows. This is 2 marks. One is for structure and the other one is for bonding. Okay, right. So here you can say giant, okay, giant ionic structure because of high melting point. Okay, the property and the reason. We move on to bonding. Okay, ionic. Okay, ionic bonding. Okay, because it conducts electricity. Because it conducts electricity only when molten. Okay, right. So we have actually stated the type of bonding and the reasoning as to why we are doing that. Okay, right. And then the next question was about calculating oxidation numbers. Okay, there are certain rules. I suppose you've gone through them with your teachers, what we do when we are calculating oxidation number for elements, okay, or for compounds. Right. So I'm just going to remove this and I'm just going to show you how to deduce the answer. Okay. Of course, in this one, you're not supposed to show working, but I'm just going to show you the working so that when you are confronted with such questions in future, you'll be in a position to answer them well. Okay, so I'm going to show you how to do the working for bismuth oxide. And then on this side, I'm going to show you the working for sodium bismuth oxide as well. Okay, right. We want to do the oxidation state for bismuth. So I'm going to call bismuth here my X. There are two of them, so I'll put 2X. Okay, it's unknown, so we put 2X. You know the oxidation state for oxygen is in group 6. Okay, it will be -2. 2 times -6 is -3 is going to give us 6. So we are going to say 2 minus 6. This one will give us 0. Okay, and then if you calculate your X here, your X is going to be +3. Remember to put the sign when you are calculating oxidation state. An answer such as 3 is not acceptable. The examiner wants an answer which is +3 because oxidation state can be minus, it can be positive. Okay, and then we move on to NaBiO3. Okay, the assumption that we're going to make here is sodium is in group 1. So the oxidation state for sodium, we're going to take it as +1. Okay, and we have our bismuth there. We don't know its oxidation state, so we are just going to call it X again, okay? And then we have oxygen. Again, our oxygen, we have 3 of them. Each one is carrying -2, so it's going to be -6, okay? If we add all these, we're going to get 0, okay? Right, so if we do our math and we move the -6 to this side, okay, the -6 will become positive, okay? And if this one comes this side, it's going to be -1. So our X for Na, for Bi in NaBiO3 is going to be +5, okay? So already you can see that something has happened to our bismuth from this side, okay, to that side, okay? Something has happened. Its oxidation state has actually changed. So when oxidation state changes, it actually illustrates either gain or loss of electrons, okay? Right, so it's moving from +3, and here we actually calculated and we are getting +5, okay? So there's a reaction which is happening here because you see our sodium actually changed, okay? It actually changed from a +3 to +5, okay? Right, so if we analyze as to what is happening, okay, there is loss of electrons there. If its oxidation state is increasing, okay, it means there is loss of electrons. When we have loss of electrons, we say oxidation has happened, okay? Oxidation is loss of electrons. But the question is saying, state the reducing agent in question 1. The reducing agent is always reduced, okay? So our answer would be our answer here would be the reducing agent is going to be Bi, okay? Bi2, okay? O3. Why? Because it's being oxidized, it's losing electrons, and this oxidation state is actually increasing. So calculating oxidation numbers in chemistry or in chemical equation can help us to indicate who is the oxidizing agent and who is the reducing agent. And as such, this equation, which you are seeing here, is actually some form of a redox reaction. By tracing to what is happening, you'll be in a position to actually deduce whether bismuth is actually an oxidizing agent or is a reducing agent. I thought we could just review this question, and I hope you've benefited from this session. If you like this video, please indicate by liking it, share it with your friends in your groups, okay? And the comments that you give to me will be in a position to help me to prepare better content for my platform. Thank you, and it's bye-bye for now.